Hello, welcome to Fun Online Teaching and Learning, another session and learning session about systems thinking. If you like the content, please like and subscribe to YouTube channel Fun Online Teaching and Learning if you like the content, so that we can create more content like this. So today I will talk about how we avoid hasty decisions using systems thinking. So systems thinking to the rescue. So today's agenda is I want you to leave the linear thinking behind, right? So I want you to adapt systems thinking, understand system triangle, to be able to identify if systems around you are collections or just stuff, and what is systems thinking. And I'm gonna provide some tools to use when thinking in systems. So I highly recommend these books. If you are embarking on a journey about systems thinking, I would like you to know about INCOSI. That's the International Professional Society about Systems Engineering. And I highly recommend to read The Fifth Discipline by Peter Sanjay, and then Donella Meadows, Thinking in Systems, and then John Moorcroft's Strategic Modeling and Business Dynamics. I am also including two links here. One is for INCOSI Professional Society, and the other one is by an entrepreneur and Professor Laila Karaulu. So it's a great website if you want to visit. So I would like to start with talking about the decisions, right? So there are many quotes that we can mention about the decisions and the quality of decisions. For example, Lewis Carroll said, "In the end, we only regret the chances we didn't take," right? And Albert Camus said, "Life is sum of all your choices." So choice means decisions, right? When we make decisions, we actually design our life and live our life. And one of the worst things that we can do is not to decide on something which is not really applicable in real world. So we have to have choices. We have to make decisions about the choices. So how can we then increase the quality of our life? Well, we can increase the quality of our life by increasing our quality of decisions. And how can we increase the quality of our decisions? Well, at that point, systems thinking to the rescue. We're going to get some help from systems thinking. So when we talk about the systems, I want you to visualize a cashier, like in this picture, okay? I want you to think of, and if you can comment below, I'll be really happy as well. I'm going to say the things that I am thinking about what kind of a system is this and what are the parts and relationships, but I would be happy if you can comment below as well. So this is a regular cashier's checkout, self-checkout station, right? You can find any grocery store nowadays. And I want you to think of parts of this system. For example, when you think of parts, if you are thinking in systems, you see the parts that are not only physical and visible as well. For example, I can see there's a screen here, there's a swipe credit card station, point of sale POS, right? There is probably if you're buying tomatoes, and well, it can ask you how many, but you also need to weigh some of the fruits and vegetables, right? So I can see there's somewhere you can put in your password. There's a place that you can use the plastic bags, but there are also things that are not visible here. For example, this little screen talks to the inventory of the grocery store, right? It talks to the banks, because when you swipe your credit card, or it must talk with the banks, right? So it should be integrated into the banking system. And when you weigh it should be able to weigh it correctly, and also it should be able to calculate the tax correctly. So if there's no tax on an item that you purchase, so as a systems thinker, you should be able to see the invisible, not visible parts and relationships as well, okay? So also in the self-checkout counter, think about the parts, properties, relationships. For example, I said this point of sale should talk to your credit card and should talk to bank correctly. And then there are requirements that needs to be considered. For example, can the customer purchase alcohol, right? Or cigarettes or stuff like that. And what are the related systems? For example, this self-checkout cashier or counter talks to the customer. There are employees over there, and there are blinking lights. There are errors that needs to be corrected, and what functions are performed, right? So when we talk about systems thinking, we should be able to identify all these different parts. So as you can see, even a little tiny self-checkout counter actually can be considered as an entire system. So designing that system, having systems thinking philosophy and application in the designing of this self-checkout counter is very, very helpful. So it's a lifelong practice. If you obtain systems thinking, really, like, it's really difficult to unlearn it. So it becomes a part of a second nature of you, and then everywhere you look, you look systems thinking, and you practice it lifelong, not only your professional life but also your personal, family, and social life as well. I highly recommend. I can't really make you watch this video because of copyright issues, but I highly recommend listen to Russell Acove. He's a modern systems thinker about the properties of systems and then how he identifies the system with his own way. I highly recommend you to watch this video. So in the beginning, I told you leave the linear thinking behind. For example, studying in an exam, right? You got a low grade. What do? Please write in the comments. Yeah, probably you say you study harder, right? You study harder. But are you studying smarter? Are you studying the correct topics, right? Are you engaged with the teacher? Are you engaged with the content, right? Are you on top of everything going on in the class or in the book, right? So just studying harder is not gonna secure you a better grade. For example, when in terms of traffic congestion, right? There's congestion, right? Like you see in this photo. Okay, so what do? We built new roads, right? In systems thinking, probably the first solution that comes to your mind is not really the best solution, because when you build new roads, now you have very crowded new roads, right? Why? Because when you think in systems, think about it. If the country has more lanes and better roads, what's going to happen? Well, people who doesn't have cars will purchase new cars because it's very convenient, it's quicker, it's cheaper. So they will discontinue using public transportation, right? So you will, because of the new lanes and better roads, you'll see more cars, and you'll see congestion back again, right? So you have to solve this in a little bit smarter way. What can you do when you think in systems? For example, yes, you can still build roads, but you can encourage people to carpool. You can give people, the companies can provide some incentives to use public transportation so the employees don't use the cars, right? You can implement some policies that the cars after a certain age, they are not allowed in the traffic, because when they make an accident, a crash, it's high likely to contribute to congestion, right? And maybe you can again implement some rules and policies and say, like, for example, the trucks, 18-wheelers will not be able to enter or take these exits, right? Maybe they are in the center of the city and the trucks are not allowed to take those roads. So that's all gonna contribute to the better roads, right? Better traffic congestion, because in this problem, the problem is not roads, it's the traffic congestion, right? So we should think in a little bit bigger perspective. So instead of linear thinking, I want you to acquire event-oriented worldview, right? So in the event-oriented world, there's a goal and situation, and there's a discrepancy. For example, you have a goal, and then you have a goal to take a good grade in the exam, right? And then you study, and then situation is you get not a really good grade or not a goal. So there's a discrepancy, right? What do? Well, you make some decisions for the next time. As I said, study smarter, not only harder. Be on top of things. Contact your teacher. Go to study a little bit more and support your study with maybe YouTube videos and other resources. And then after your decision, what do? You take action, right? And there are some results. So this event worldview, which is the linear thinking, what do you see here? What is missing here? Well, the missing is the feedback loop. So this event-oriented linear thinking behaves like in our lives. There's only one event, there's only one discrepancy, and there's only one decision, and there's only one result. However, that's not the case, right? The world is more complex and more VUCA than that. So that's an event, but the solution is not a fix. So because things and solutions and implementations, our decisions are not happening in a vacuum, and there's no one situation that we need to decide. There are more. So which means on the left, you say traditional thinking, right? One event and one problem and one solution. Whereas the systems thinking, you have multiple feedback, you have different loops that connect the same nodes and stuff like that. So I want you to move from traditional thinking to systems thinking, which will make you more successful and more promotable. Okay? So then what is the feedback worldview? So just a little bit tweak when we were drawing the linear thinking as problem and fix, right? Instead of just drawing it linearly, I want you to draw like this: goal, situation. Now there's a discrepancy, right? This is a problem. This is the same thing. I just use a little bit curvy lines, and then decision, and then action and result. However, because I kind of presented that in a loop kind of a picture, right? Now you can understand and guess what is missing in this picture. I'll pause a few seconds. What is missing in this picture? How can we complement this picture? Well, we can complement this picture easily. This solution, so action and result feeds back into situation. So just the example that I gave you, you got a little bit lower score than you aimed, right? Your goal. So this result, what does it do? Well, it feeds into the situation, and it impacts the discrepancy. So your discrepancy will be a little bit lower, right? So it's improved, but it's not zero. So then you make the same decision, the similar decision to study harder, and then now you have new action. However, what is this yellow thing? This is feedback, right? The decisions we make, we take actions, and then actions have results, and they have multiple results, right? And then they feed into situation. So if this loop is broken, and if you don't consider the feedback, it's like a blind person, right? You don't know where you're going. There's no feedback, right? So, however, systems thinking adds on top of this picture, not only creating feedback, not only drawing a little bit curved lines, it also considers that action and results creates new decisions, new results, and they are all interconnected and intertwined. It's harder to solve these kind of problems, but that's the world we live in. So we also must consider in systems thinking second and third order effects of our decisions, because there will be unintended consequences. When we act on something, when we do something, there will be effects that we didn't really consider, right? They will cause maybe new problems. They will add new layers to the problem and the situation, and will add to our discrepancy. And I love this cartoon a lot, right? So you don't want to, in these situations. And also, you don't want to be in this situation, right? Every time you push a slab, the slab might collapse on top of you coming from another direction, right? Say you send an email to somebody, you never know whose desk or inbox the email will end up, okay? So you write an email to someone in the company complaining or saying bad words, and then he forwards it to another one, and then they forward to your manager, and then your manager comes back to you, right? So just like in this picture. Because we really need to understand the systems thinking, because being naive and not being aware of the systems thinking and systems, it's not gonna help us. For example, it's not gonna change the result. So if you don't know the system, how come you make good decisions? Okay, for example, I have a bestie, right? So they put in unintentionally kind of maybe a poison or something, right, in my coffee, and then I have a bad actor who wants to put poison in my coffee, right? Guess what? What is the result? Well, the outcome is the same. I'm injured, right? I'm hurt. So it doesn't matter my friend not knowingly doing it, and the bad actor really wants to do it. The result is the same. So every time we all live in systems, right? You gotta know your system. You gotta know your parts. You gotta know your relationships of the system, the objectives of each part and system, right? Then what is a system? Let's cover that in the next video, okay? And if you like the content and if you want to see more of these, please subscribe and follow the content, and turn on the notifications, please. I would really happy to see your comments below, because I read all the comments. Thank you. Hello and welcome back to Fun Online Teaching and Learning channel, where we learn about project management, risk management, systems thinking, and professional soft skills development. So if you really like the content, please subscribe and turn on your notifications and follow the weekly new content to learn about those topics. And thank you in advance. So the previous video we left off where we started talking about what is systems engineering, but I want to make a quick recap about what we did in the previous video. So we talked about linear thinking and then feedbackward thinking, and we looked at what is system and the tools. So I recommended these books for you, and there's also in Cozy website and then the other website that you can find great resources about systems thinking. So systems thinking is actually help us increase our quality of decisions, and then as a result increase our quality of life. So please get some help from systems thinking. And we looked at self-checkout cashier or counter, and then we studied what kind of a system is this, what are the parts of the system, and so on. And systems thinking is a lifelong practice where you will not only use in your professional life, but also social settings and family life as well. So I want you to leave linear thinking behind, and when you have a congestion in the roads, just building new roads will not help us, because the roads will be even more crowded, because people will not use the public transportation, and because the roads are attractive and comfortable and quicker, they will get more cars, and then more lanes and bigger highways will still be congested. So here the problem is not building new roads or the lack of roads, but it's congestion. We also gave some examples, so you can check back the previous video. I'm gonna include a link in the descriptions as well. So classic linear thinking is like this. So you have a goal and situation, and then there's a discrepancy, and then you make a decision, and there's an action and result. But instead of writing it linearly, I want you to draw it in curves, okay? So when we start situation, goal, and discrepancy, and start creating it and drawing it as a loop, we can easily see that we need to close that loop, right? So every decision, after decisions, we take action, and every action has results, and then the broken link is the feedback. So also our actions will actually result in other actions and other situations, and will cause other decisions. So please review the details in the previous video. and there will be unintended consequences, right? If you push a slab like in this picture, then probably you will it's gonna collapse on you again, right? And if you don't understand the parts and really how they relate to each other and what is the consequences of it. Having good intentions in the systems is not enough, so you really need to understand the system in a timely manner and understand its functions, relations, properties, and objectives, because being naive does not change the result. If my friend accidentally puts detergent in my coffee and a bad actor puts detergent or poison in my coffee, the result is the same. I get hospitalized, I get injured, right? So we need to understand the systems. Okay, after this recap, I want to talk about then what is a system? How can we identify a system? So basically, there are many definitions about systems, but one I like is a system is a set of things interconnected, and please be careful with pay attention to the colored text, in such a way that they produce their own pattern of behavior over time. So that's according to Donald Meadows, a systems thinker and a professor. So a system is a set of things. So if there's only one thing, then it's not a system, okay? And there are many things and they are not connected, that's not a system as well. So there should be more than one thing and there should be connected. And then they should have their own pattern behavior. And the most important thing here is as well, the behavior over time. We look at the systems and we try to understand the behaviors over time, because their behaviors will be stochastic, right? And I highly recommend you, if you want to learn more about systems thinking, please read her book, Thinking in Systems. Systems response to those forces is characteristic of itself, and the response is seldom simple. So even though you understand the system, the parts, the properties, the relationships, it's gonna be really difficult to understand what the next response will be. Like I said, it's gonna be stochastic, right? And the solution is not always simple. What else is a system? So another definition here, just to let you know that there are many definitions: a set of interrelated components functioning together for a common objective. So even though it looks different, actually it's the same, right? They need to be interrelated. There should be more than one component, and then they should function together for a common objective. So they are still objective. What's the ultimate objective of a system? It's to satisfy the user's need. In the previous video, we looked into the self-checkout counter for a customer, right? So the ultimate objective of that is to satisfy the user's need. Just pick up your grocery and scan them easily, put them in plastic bags, and then check them out. If you can do that, then you satisfy the customer's need. So now I want to differentiate what is a collection of stuff and versus a system. Okay, so to identify the things as system, we need to look in three things, and I call it system triangle. So things need to have purpose. The system itself needs to have a purpose, and then parts have purposes, right? And some literature will call it function, properties. They're all the same. The other angle in the triangle is the relationship, linkages between parts. So which parts are related, what impacts the other part, right? So these are the questions you want to ask to understand the system. And again, being naive about the system doesn't change the outcome, right? If your employee doesn't know the system and make errors and make the company spend more time and money and effort on the things that they shouldn't spend more, then it's naive, right? The result is just wasting money and time and expertise. And the third one is element. Some literature will say parts, attributes, components. They're all the same. So when you look at these three things, if they exist, what you're looking for is a system, probably. Okay, so let me give you some examples. But before that, I want to say that the system is more than the sum of its parts. And not part alone has an independent effect on systems properties. Okay, but I want to use product instead of sum, because when you put things together, you see that the final outcome is more than what the parts can do, right? So think about a car. The car has steering wheels, tires, electronic components, electric components, engine, and then if you just sum them up, it's not gonna bring us from A to B, right? I mean, any part of the car cannot bring us from A to B, right? But when they are together and function together for the common objectives, then they can and do their own objectives, right? On functions, then I will be able to travel from A to B, right? So that's what I mean here. What are the properties of system, right? So think about it. Who writes on a piece of paper? Can you comment below? What do you think about that? What or who writes on a piece of paper? It's also from a philosophical perspective, right? I mean, the probably like build new roads or study harder to exam is probably similar to that. And we would say a pencil writes, right? Then get the pencil, put it on a paper, don't touch it. Let's see if the pen writes, right? If the pen writes. Give the pen to a person who doesn't know how to write and read and write. Can they write? No. So it as a system who a person is a system who has the muscles, the pencil, the paper, the intellectual, the cognitive level, who knows how to write and write, knows the alphabet, right? Knows what to write, then they write. So who writes? The person with those skills, right? Not a pencil, not a paper, not a hand, not a finger, okay? What carries you from point A to a point B? Actually, I alluded to it a little bit. A tire will not, a steering wheel will not, an engine itself, it will not. Take the engine out of the car and see if it carries you from A to B, right? So the car as an entire system can only carry us from point A to B. What is life? And who is living it? Well, the life is as a whole your system. Who is living it? You are living it. So sometimes in life we blame other people, right? Hey, that employer was bad, that city was not the best city that I can live. My parents were not rich, so I'm broke as well. So this kind of thing, who is living it? So if you think in systems, you will see your life as a system, and then what you will do is take ownership of the system, which is your life, and then take the full responsibility and try to design and change it, right? So the life is yours, no one else's. Everyone lives their own life. Okay, so you can be a student, an engineer, a mom, dad, a taxpayer, right? Project manager, a dad, a neighbor. You may be a mom, maybe a project manager, trying to juggle between schedule, cost, and performance. And you can be friends, but don't let your life be a collection of stuff. When life becomes a collection of stuff, when it doesn't have a meaning, when it doesn't have a systems level objective, when the parts are not related, right? So I want you to look around and then identify your life parts and components and relationships, and put yourself in the center of your life and take full responsibility of what you're living, okay? Because you are living. Okay, after that, what are the types of systems? There are many types of systems, but mostly engineers are interested in human modified or engineered system, right? We change and create systems as humans, right? There are also natural systems. It's evolved without human interaction. And then there's conceptual systems, static systems. Conceptual systems would be like math, right? When you do a dash in math, a dash is a subtraction, right? When you do a cross in math, it's addition, right? So these are all symbols. What is even alphabet, right? These are all symbols that we all memorize, and then we agree that S is S, right? And then we all use it. So that's conceptual. And static is structural component whose state does not change, like a bridge, right? You can build a bridge and structural components doesn't change, meaning if there's a the wind blowing, and there's a rhythm, there's a resonance, then it may collapse, but meaning that the component is not changing over time, naturally or unnaturally. There are also physical systems manifested in physical forms, and there's dynamic combined structures with operating components. I just want to give some examples. For example, is this a collection or a system? So let's see, just like this picture, right? Is it a collection or a system? So that's actually a system, but I wonder why. Can you comment in the below, in the comment section? How about this one? Is this a system or a collection of collection of stuff, right? A fruit basket, just like as it is. Is it collection or system? Collection of stuff or system? How about this one, right? Kids are playing soccer. Is the team a system or a collection of stuff? When I say collection of stuff, it means like they are not related, they can't work together, right? For example, those apples, can they work together? Think about from this perspective. How about this collection of tools in your garage, right? Can they coordinate anything? Can they do anything? Can they relate each other? No, not like this, right? How about a kitchen? A kitchen by itself with washer, dryer, dishwasher, all the tools and drawers and windows. Is this a system? To be honest, it's not. What is missing in this system? To make it a system, not a collection of stuff, there needs to be something. And what it is? What it is a human. Someone needs to be there to use it, to relate the tools, to make them, to coordinate them, to be able to bake a cake, wash the dishes, wash the clothes, right? Because without a human, these are just collection of stuff. So without you, your life is not a system. Without you, your life is just a collection of stuff, and it's not so much fun. Okay, so turn your life into a system, please. So you should be in the middle. So like in the kitchen example, you can do the things that is designed to do, but if it's missing you, your life will be just a collection of stuff. How about real examples? Sure. Constitution, right? It's an example. Solar system, it's an example. Smart transportation system, it's a system. And community, family, person, individual, these are system. Human body, multiple systems. Actually, we can call human body a system of systems. And I recommend the Peter Sanjay's Fifth Discipline book. It's rather difficult to read. It's 400-500 pages, but if you read it, it's gonna add to your systems thinking, literature, and understanding. Then what is systems thinking? So after identifying the systems, we need to see what a systems thinking is. It's a way of seeing and understanding a situation that emphasizes both the parts and the relationships among the parts rather than the parts in isolation. Like I said, a tire, a steering wheel, an engine will not bring us from A to B. A car can, right? So it's the seeing and understanding both parts and their relationships, and also understanding that the parts are not in isolation, right? So that's systems thinking. And I want to pause it now here, and then I'll continue with more content next time. If you like the content and if you want more, please subscribe, and this will tell me that you want more, and turn on the notifications, follow our weekly content. And then thank you so much, and see you in the next video. Bye bye now. Hello, welcome back to Fun Online Teaching and Learning YouTube channel. It's good to see you back again. If you like the content we produce, please subscribe and turn on your notification so you can follow our weekly updates. And thank you in advance. So this is another video that we are covering the systems thinking. Okay, so far we talked about what's linear thinking and what's feedback thinking, and we defined what a system is and how can we identify a system using the system triangle, and then how can we differentiate a collection of stuff versus the systems. And then we looked into what is systems thinking. Okay, so I highly recommend you to check out these resources: Fifth Discipline by Peter Sanjay and Thinking in Systems by Donald Lamedo, right? And you can check out the INCOSY's website as well. It's the International Professional Society about Systems Thinking. So this is the definition, right? A system is a set of things interconnected in such a way that they produce their own pattern of behavior over time. So if there's only one thing, it's not a system. If there are multiple things and they are not connected, they are not system. If they don't produce their own patterns, it's not system. So to identify a system, I use the system triangle like a ruler, right? So the system needs to have purpose, relationships, and elements. So there are different names that we give in different literature. Purpose can also be function and properties. Relationships, some literature says linkages, right? Elements are parts, components, and attributes. So you can be a taxpayer, engineer, project manager, you can be a mom, dad, but if you are not in the middle of your life, because you're living your life, so if you don't assume full responsibility of your designing your life and living it, then the life becomes a collection of stuff, which is not really the desired outcome, right? So you have to put yourself in the middle of the life and then assume the responsibility and design and live it. So what are some of the real examples of systems? There are symbolic ones: constitution, legislative, executive, judicial. There are natural ones, solar system. There are engineered ones like smart transportation systems. There are, again, engineered and community-based one, district, school, right, individuals. And there are natural systems, again, like a human body. I actually want to see this systems of systems, right? There are multiple systems in our body. Then we covered what is systems thinking. It's seeing and understanding a situation, the parts and the whole and the relationships, and understanding that the parts are not functioning in isolation in a vacuum. So what is the power of applying systems thinking then? Well, think about it. You have resources, right? And your resources are, it can be an expertise, money, it can be time, it can be a location, some sort of decisive factor amongst the competitors. And let's say it's 2-2-2, right? So systems thinking actually makes you put them together. So if you can understand the parts and relationships and the functions of each and objectives and how they impact the system level objectives, then you have a value of 222, right? Twos are individual, but when they work together, when they correlate, when they relate each other, when they function together for a common cause, then you have the value of 222, correct? So this is a healthy system. An unhealthy system will look like, well, if some of them are working together, then at most you can have 22, right? Or you can group them like this, you still have 22. You can group them 2-2-2 and put in the work, but then they work in silos, and then you have only two, the biggest value, the largest value. If you can organize them in a wrong way, you don't understand their functions and relationships, then you can have this kind of a organization or this. So none of these are 222, okay? So that's why systems thinking requires a holistic approach, and it's not written like this, correct? And some of you are really good at the spelling, so correct me. Yes, this is not written like that, it's written like this. So it requires a holistic approach. Just like the example I did, right? 2-2-2. If you don't understand the value of each two and then make them work together for the common cause, the common objective, from a holistic perspective, then they just have two, value of 2, correct? So I want to give you an example of the blind man and the elephant, okay? And in this picture you can see the elephant as the company or a product that everyone needs to march forward and meet the monthly and annual goals and make money, make sales, right? So if there are blind men around an elephant and they don't see, they don't hear, correct? So one holds the tail and then says an elephant is just like a brush, right? Because he's not seeing, he's not hearing. And in this case, really, if you make your employees not think in systems, but you make them work in silos, that's what's going to happen. They will not see the big picture of the company. Okay, and then you can, as a CEO, as a manager, senior level manager, you can preach them all day long, right? Let's make this elephant move. Let's make more sales. If the individual employee or unit or or department is not seeing the big picture, not seeing the holistic value, not seeing the systems value to the organization, they can't do it, right? So my question to you is, and if you can comment below, write in the chat, I'll be really happy. How can you improve this situation, right? How can you improve this situation, this understanding? I'm gonna pause a bit and then let you type. So as a matter of fact, you can improve the situation as a manager. How? You can give them eyes, which means you can let them experience what they are touching with eyes. So add more visuals to the situation, correct? What else can we do? Well, another thing I want to do is, as a manager, to improve the situation is give them talking, give them speaking abilities, so that they can coordinate, they can speak, they can email, they can share information with other employees and departments, correct? So that also increases the understanding. One thing I also want to add is if you can move the roles of employees, correct? So make them, I don't mean like permanently, but let them work in other teams, see what they are doing, and add to their knowledge and experience. So this way they're going to see the elephant, and from a marketing perspective, they will understand what the manufacturing guys are doing. From a quality perspective, they will understand what the salespeople are doing, and they will sympathize with others, and they will contribute better to their function, okay? So these three things, I think, can easily improve the understanding of this elephant. Otherwise, you can preach all day, all night, and then the elephant will not walk, which means you're not going to make more sales, you're not going to make a better product, and you're not going to have a better company. So systems thinking really helps us. So it helps us understand the system, like in the elephant case, right? Systems are big, they are apart. So nowadays companies are not different geography in one country. They are dispersed around the globe, which is like different countries, different even continents and cultures, correct? So it really helps us understand the system and then describe the system to others. Like the elephant case, if you can increase the communication within the departments, within the employee, everyone will understand the system better. And then once you understand it, you understand the elements, the functions, how they relate to each other, what requires to move this elephant forward, what requires for us to make more sales, make the employee happy, right? Meet the annual revenue targets. And then once we understand those things, we kind of find better solutions. We can understand what kind of leverage points they have and how can we influence the system. So this kind of a big elephant, right? If you order the elephant to walk, it would not. So you have to entice him, you have to influence the elephant, correct? So the system is the same. So how can you find and identify the leverage points? What can you do, and how can you influence those points, right, to make the elephant march forward? And you can explore new ways, and then minimize systemic mistakes and expand the choices of solutions, right? So there are 4 ways actually we can handle a problem. So we can do absolution, we can do resolution, we can do solution, and then we can dissolve the problem. Dissolve the problem means redesign the system. Absolution means just don't mess with the system and hope the best, right? Resolution means just do what is enough, right? Not to find the best solution, but what is enough, kind of optimization. And then solution is really what we really understand from solving a problem, right? Find the best. solution, do the root cause analysis, find the root of the problem, and evaluate your alternatives on how to fix it, with a less cost and quicker. That's solution. And this solve is redesign the system so such a problem will never occur again, right? So there are 4 ways to handling a problem, and then we can make better decisions. It allows us to grow, because systems thinking is not only professional, for society, for personal life, for social settings as well. You can use systems thinking, and it increases our perspective, increases the diversity, understanding other people's ideas and other departments' challenges, right? And even so, one system is comprised of many systems, right? They have subsystems, they have components, and they have simpler systems, which is maybe the parts, right? It also has like system of systems as well. So when you map out your system, you really have to try understanding not the system, but the environment the system is interacting as well. Remember in the first session, we talked about the self-checkout counter. And then we talk about like they need to talk to IRS for tax issues. They need to talk to banks for swiping the credit card, right? They need to talk to inventory, the database, so that when you scan a tomato or a milk, it becomes you can see the photo as a milk, right? Not a wrong product. Like I said, you should even think of systems of systems. Right? So because the system of interest is just a system, but it interacts with other natural and business and research and legal systems as well. Understanding the related systems and how they relate our system is a huge addition to understanding the ecosystem, which is going beyond your system boundaries and understanding the system of systems, okay? Think about a military case like this, right? You are an infantry in one of these hills or somewhere, right? You need to understand that, like, how can you communicate with a satellite, with an artillery, with an air force, with a ship, right? So you need to understand your ecosystem, not only the tools, whatever gadgets you have. It's not enough just understanding that. You have to understand the ecosystem. So in a way, systems thinking focuses on the entire problem and optimizes the whole, not the parts. Think about it this way. You're going to gym and you are only working your right arm, okay? So the right arms, you're increasing your, pumping your right muscles in your right arm, and you don't do running, you don't do lifting, both hands, both arms. Then it's not gonna be symmetric, it's not gonna be the best, right? So if you focus on the parts in a company, then that's going to be similar to the gym example. For example, let's say in the company the sales are down. If you fire the sales manager, that means you're only focusing in the sales department, but probably it might be very well that the problem is from the quality department. Maybe they are skipping tests and they are shipping the defect product to customer, and you get a lot of complaints. The company reputation is lost, and then that's why you don't get new customers, and old customers are not reordering. You see what I mean? That's why you really need to understand when sales are down, you need to understand the entire problem, not only fire the sales manager, correct? So for that, don't work in silos, okay? And sometimes the least obvious part of the system is very crucial. That sounds like a trivial thing, right? Or we already know. But let me give you some examples. So a car key doesn't seem a big part of a system, correct? So it's really like we don't even think about it, right? And some cars even don't have keys. Or turn on, turn off button for a computer. We don't really think of these things. But how about if you are late to the work and you lost the keys and you're looking to keys everywhere in the house, at work, you can't find it. Then it becomes the most crucial function of the system, which is your car, right? Or you have the computer, all the software up to date, you have a great screen, it's light, it's better, but turn off, turn on button is not working. So as you can see, you have to take care of every button, every part of the system. So none of the parts are most important than the other sense, and most of the time least obvious ones becomes more important in crisis times, right? For example, the smartphones started like a phone, but we feel like they are computer nowadays, right? That multifunctional tool was less obvious in the beginning, but now it's the most crucial thing. And then systems thinking suggests that reductionism is not gonna help us understand the system. Okay, when you break it into parts, like a car, and you show it to someone and never saw a car, probably doesn't understand. And also, two halves of a car is not a car. So that's why I keep saying, like, assume the responsibility of your life and then design and live it, right? The best way to create your future is to design it and to chase after what you want. For example, there's a ticket that you want to attend, right? And there's free pizza, free soda, but if you just see it as soda, as free drinks, free pizza, and a great night, then it's kind of it's not really a systems thinking. So you should be thinking about, like, what can I do? Who can I meet? How can I add to my contact list? And how can I network? And then this ticket becomes, or this event becomes more than an event, and it helps me create my future. Who is attending? What can I ask them? How can I break the ice with them, right? How can I get their LinkedIn account? How can I get their email and phone number so I can follow up with them and then improve my relationships and networking, correct? So this is the way that systems thinking will help you. And I want to stop here, and next time, in the next video, we're going to look into an iceberg model, which is widely known in systems thinking. And then we're going to look into how can we use this for the events that we see around us. Okay, thank you so much for being here and watching the video till the end. If you like this content, please subscribe, turn on notifications, and follow us weekly. Thank you, and see you in another video. Hello, welcome back to Fun Online Teaching and Learning. It's nice to see you here, and if you are here, you're probably wanting to learn about project management, risk management, systems thinking, and professional development, as we call it, lift skills or soft skills or interpersonal skills. If you like the content and the channel, please subscribe and turn on your notification and follow us weekly updates. And I thank you in advance. So what we have done so far in the previous recordings is I recommended these books for you to look at and read more about systems thinking. And we define systems as the set of things interconnected in such a way that they produce their own pattern of behavior over time. And that's according to Donella Meadows. She talks about it in Thinking in Systems book. As you can see, if there's one thing, it's not a system. If there are multiple things and it's not connected, it's not a system. If they don't produce their own distinct behavior and pattern over time, it's not a system. So if it's not a system, what can it be? It can be a collection of stuff, and meaning they are not related, they don't work together, they don't have a common objective. It's like apples in a basket, or tools in a mechanics toolkit. Or a kitchen with washer, dryer, and everything, but there's no person in the kitchen, there's no mechanic to use the tools, and there's no one to eat the apples in the basket, right? Different fruits in the basket. So that means they are not systems, and they are not connected. Then question comes up, how do I identify the systems, right? So you have three things we already covered. So if you want to see more details, you can see the description, the links for the previous videos. There should be a purpose, function, properties. There should be a linkage, a relation, and there should be elements, parts and contributes, the attributes and components. I want you to look at your life from a systems perspective. Don't let your life to be a collection of stuff which is unrelated. If you don't take full charge of your life and don't see it as a system, you just see it in fragmented parts and here and there, and you don't really connect the things. You don't really connect the dots. So I want you to be a system thinker and be in the middle, in the center, in the core of your life, and design your life and create your own future instead of waiting it to be a random future. And we also looked at the systems thinking, which is seeing and understanding the situation, the parts, the relationship, and how they contribute to the overall picture, overall system value. A healthy system, we have resources. Let's say one of these two is money, the other one is expertise, and the other one is time. If you put them together in a healthy system, then you increase the value and you have a 222. But if you don't have a healthy system, if it's unhealthy, then you organize it wrong, and the most you can have is 22, right? In most cases, you only have 2. So if we don't pull to the same side, if we pull the opposite side, then we're not going to be able to create the system value. And I gave an example in the previous video about an elephant. The elephant being a product, making sales in a company or a big company. If you don't let your employees and departments talk, share information, see each other's work, and sympathize, then the company will not be able to move forward like this big elephant, because no one sees the big picture, right? You can preach all day long as a CEO, as a manager, as a leader. It's not gonna make sense for the employees, because they don't see the big picture. You can improve the understanding by letting them see, but letting them hear, letting them share information, letting them understand what the others are doing, and sympathize with them. So systems thinking helps us understand, describe the problem, analyze the problem, find solution, minimize the mistakes, expand the solution space, make better informed decisions. We all covered that in the previous video. And also, systems thinking is not enough. You have to think in systems of system, right? Because every system we have has related systems, and then they exist within an environment. They don't exist in a vacuum, right? They are relating to other natural resources, research, political, legal frameworks, other businesses and laws, and financial systems. So now systems thinking, you have to expand it on to systems of systems, okay? And we also talk about the least obvious part of the system might be sometimes the most crucial one. And I gave the example of a car and a turn off, turn on button for the computer. We don't really realize that. We don't care about keys and button, but if the computer turn on, turn off button is not working, you can't really open the computer. And sometimes when you launch product, like in this case, like the smartphone, then you think it's a phone, but then it becomes a tool, it's a functional tool that really connects people, and most of the features were not really obvious when we first started the smartphones, right? And then we talk about reductionism is not enough. You have to analyze and then synthesize, right? Break apart things and then put them together back again. And then half of the car is not a car. In this specific session, I want to talk about an iceberg model example. So iceberg model is, you have to look for pattern and mental models and be aware of the mental models when you want to see the systems, understand the parts and relationships and objectives and functions for attributes for each part, and also the system level value, okay? So for example, when you're walking on a street, you see a soda can. What do? You probably pick up the soda can, right? Great. How about the next day when you're walking the same time, maybe the same day, the same street, you probably will see another soda can, right? And then you start understanding a pattern. And you also see that because of so many soda cans, now the trash bins are overflown, maybe by the wind or people putting more soda cans and trash than it really can hold, right? Now you see another problem. And what do? You write the city, you make them put more trash and stuff, more trash bins, and hopefully it's not overblown by wind now, but you still see soda cans around, right? Why? Because people are not probably using the trash bins, although they are there. So if you would put this example in an iceberg model, when you see the first soda can, it's an event, right? It's what is visible in the iceberg. It's what is happening, right? So it's happening that there's a soda can on the street. And then the next day I see the same soda can and overflowing trash can. Now I see a pattern, a trend. People are not careful about putting their soda can in the trash, just kicking it on the street. And also I see a pattern that if people try to put it, it's overblown by the wind, and the trash bins are not enough, right? And then now I try to understand what is hidden, right? So the only visible element is event, right? And then under the events, under the water, you have the patterns and trends. The event is what's happening. Patterns are probably what's going to happen, right? And then the underlying structures, I want to understand, like, why is this happening? Why am I seeing soda can on the street? Why am I seeing overflown soda cans and trash bins being a lot and pouring out from the trash bin? And now I want to understand underlying structure, which is deeper than the pattern, right? In the invisible, the hidden side of the iceberg. How can I influence? What is influencing the situation, right? And then the deeper end of the iceberg tip, the bottom tip, is mental model. So these are the underlying culture and beliefs that fuel the structure, that fuel the patterns, and that make me see, because it's only visible part, see the event, the soda can on the street, correct? So if you want to understand the system and use solution and increase your solution space and quality, then you have to look for patterns and mental models, okay? So probably you know the usual hierarchy of data: information, knowledge, and wisdom, right? When we put data in context, it becomes information. When it's relevant, it becomes knowledge. And then when I put some vision in it, it becomes wisdom, right? So if you I want to overlap this with the iceberg model, which I really need to turn this like that, because events are data. That's the thing that I see on the street, soda can. And information is pattern, because when I give a context, I see soda can every time I walk, so it's an information, right? And I want to understand, I want to know what is the underlying structure, why I'm seeing like soda cans around. And then I want to be wise about it. How can I change it, right? When you start thinking in this model, you really started understanding the systems. So the only thing you can do for a data is react, right? You see a soda can, you put it in the trash can. But when you understand the patterns, now you start anticipating what's going to happen tomorrow and the next week, right? And then once you got that information, now you want to know and design to attack the underlying structure. You know what? There's not enough trash cans, so I'm going to write to city and go to meetings, city council meetings, and I'm going to demand more trash cans on my street, right? And then one step further you can do is transform, right? So if the trash bin is full, you want people to carry their trash, soda can, and then discard it in a trash bin that is available to them, that's empty, maybe next to their home, wherever they are walking, wherever they are going, right? You want to transform the culture. If they can wait a couple of feet and put it in an empty trash bin, right? That's transformation. That's not easy to do. That's not apparent, and that's not a quick fix. But when you change and transform the people's mental models, then you will not see soda cans, right? So iceberg model in systems thinking is so much important, and there's so much implications that we can use in the real world. And the next time when we are together and when you join me, we will discuss about some of the practical applications of systems thinking. What can we do in our practical life that's going to help us with our daily work, daily task, and become a better employee, become a better entrepreneur, be a better dad, and live a better quality life. Okay? But so far, if you like the content, please subscribe and turn on notifications so you can be notified from the new content. And I especially thank you because you watched the video till the end and helped my channel grow. So I really thank you for that, and I really want to see you here in the next video, and stay safe.